We have Jasmin Jahić from the Computer Lab, who's going to talk to us about some principles for software architecture design and sort of two ends of the spectrum and maybe finding a happy medium. So I'll let you go ahead. Thank you very much.
Okay, so the topic is software architecture between rigid process and somehow manage. So it's yeah, let's hope it will be somehow as a discussion. So when we talk about software engineering, basically we have two scenarios. The first scenario is we have an idea, we do some coding, and then our software project which is ready. The second scenario is we already have a software project, we have product, we have some idea what we want to do or change there. Then we try to understand the code for the previous software product, and then we do some coding, and then we have hopefully better software product. What are we actually trying to do is we have an idea about changing something which is related actually to solving some problem, that idea, and together these two we can classify as a problem domain. Now, when it comes to this problem domain idea that we want to do something and the problem that we're trying to solve, the question is, how do we personally understand something that needs to be done? That is if you work alone on something. So you have your own project, you want to work on it, and you're trying to understand what is it that needs to be done. Now, if we work in a team, the question is, how does a team understand the problem domain? What needs to be done? What is the idea and what is the problem that you're trying to solve? And do you have a common understanding between team members? So you might have seen this picture before. Yes, most of you, right? Yeah. So it starts really with this idea of the problem domain, how someone who is a customer, in which case you can be a customer as well, explains it to some stages through which the message is lost. Of course, if you're the one who is the only one who is working on it, well, you could be defining your problem, but you usually will be inspired by the market, and already here you have this translation. If you work in a bigger team, well, this is usually something that we have. So the message is somehow lost in between. Now, from the left side, we have that problem domain where we already see the issues that the message is somehow lost. On the right side, we have the solution domain. Basically, what is the solution that we're trying to achieve? And then we have a translating of that solution into the code. Now, the challenge with the solution is the same the challenge as we had with the problem. If you have a team of people, do all of them understand what is the solution that you're trying to reach? Do you have a common understanding? Do you understand parts of the solution? Where do you stand on this? Do you have this common understanding? So those are two problems that we see in software engineering as I presented. So we have a lack of understanding what is the problem, and we have a lack of understanding what is the solution. Now, surprisingly, this somehow works in most of the times. So somehow there is that problem that we're trying to solve. Somehow we have an idea of a solution, and somehow we reach the code. Usually it works. Well, it works in these cases. When you have a team which is very enthusiastic, when you have a team which is very knowledgeable, and it works if you're lucky. Those are somehow preconditions. And if you have all of these three, you could be ending up with a great success, great results, something that is okay in terms of software, or it can be a failure. How do you predict where do you land if you somehow just manage something in software engineering? Well, there are people that think that they can solve everything just by coding. Okay, you know how to code, you're really expert in C, C++, Java, whatever. Okay, you just do the coding and you can solve everything. Yeah, not really. Why not? Because there are other issues that we face here. What about onboarding new members? So I don't know if you had this issue when you're trying to get someone new in the team. How is that going? Yeah. What about when you actually have to take over an existing project? What about when you try to integrate the work from different teams into a single product? These are, you could say, high-level challenges, but you also have these low levels. So, okay, you have a lot of work. How do you prioritize? How do you make decisions that we discussed? Okay, what is the solution? How do we reach that point? Coding, once we know it, okay. you have to know how to program, but what is the solution? How do we decide about that? How do you manage discussion between different teams if you have several teams? So, and finally, what about different stakeholders? So, okay, if you're working just with the fellow engineers, you might have quite fruitful discussion, but what happens when you have grant donors, when you have administration, where you have other people from other domains that you're trying to convince what you're trying to do? HR, is coding just enough? Yeah, so when we actually say software engineering, what we're actually saying is you have all of these organizational challenges, timeline, division of work, role responsibilities. You have to ensure common understanding on some level, and you have to ensure the transfer of knowledge. Now, if you put this into some sort of the timeline, past can be described with some sort of documentation, literature. In present, we actually have decisions what we are trying to achieve. To achieve those decisions, we have to have a common language, that we have a common understanding, and then for the future where we're heading, we have to have some design. So essentially what we want to achieve is we want to make this success, if we succeed once, reproducible. In some cases, if you're using Agile, we want to enable this incremental development. And like I said, all of this communication between different stakeholders and support to your decisions. Now, if you have superhero developers who have no memory loss, who stay forever in companies or teams, or when they transfer, they do the transfer of knowledge properly, if they can translate between different stakeholders, understand what marketing wants, what people from biology wants, what people from chemistry wants, and translate that into engineering, or if they are able to communicate and understand problems and solutions without any issues, you might be even able to achieve this. So where are we actually currently? So you have to have all of this: enthusiastic people, knowledgeable, lucky, superhero developers, and somehow you will be able to achieve your goals. Yeah. So the approach of somehow I manage without any additional process around it is not good enough. What we usually refer to, as what I've described here, is the implicit software architecture. So you do not actually prescribe how do you reach your end goal. You don't prescribe how you're going to build the product. But somehow things evolve organically. And like I've said, it works in many cases, but all of those things are always under a question mark. So why not make everything explicit and document everything? Because if we're making explicit, we also want to document all of these processes and how do we actually achieve, how do you reach this product. You might have seen this B model, maybe not. It's quite outdated in software engineering. So basically you start with the requirements, you do the design, you do the implementation, then the testing, and you do some operations. Quite outdated, but outdated in terms of alignment to the operations. Now we have continuous engineering where all of these operations overlap, but it's a good idea just to see what is actually involved in making a software product. Now, if we put this into a proper software architecture terms, what do we usually have is that we start from the requirements at any point. Requirements are nothing more than wishes and concerns of the stakeholders. I want to have something. You can be a stakeholder. Okay. Are requirements good enough for making software product? No, they're not. The reason why they are not, because usually what you need to make a solution is not in the requirements. Just because someone wants the button to be of a red color doesn't really help you at all. Another thing is usually what you need is not specified here, or is specified with not enough details. What does it mean to have a fast software? 5 seconds, 5 milliseconds, 5 hours, if you're translating how many terabytes of data, and if you do some experiments, it really depends on the context. So what we usually have in the requirements is lack of the information that we need for the software products. And that's why it's the job of software architect to derive something which is called drivers. What is actually driving your product? Try to extract from the requirements, or by assuming or by additionally talking to people, what do we actually need, what is driving your project. And those can be business drivers, which are then translated into the functions and into the qualities that your software has to achieve. In between, you have the constraints on all of this. Once you know the drivers, you're going through the design space exploration. In the design space exploration, we're actually trying to understand what are good solutions? What are adequate solutions for our drivers? And there can be dozens of them, so we try to compare them and so on. We come up with the solutions, and then we go towards implementation. Now, if we do it requirements to implementation, it would be classic waterfall V model approach. So we usually don't do this anymore. We do it on a very short cycles. These days we have a continuous engineering. So we have process and methodologies that has to be able to accommodate all of this, what I said. Another thing when you talk about software architecture is, where do these solutions come from? So if you will be trying to make a new solution every time when you have a software product, you will be losing a lot of time. Most of the time, we're just reusing things. So we are using, for example, microservices, we're using modular monoliths and so on and so on. So there are already many solutions out there. So if you think about, okay, there is a problem, there is a whole set of the potential solutions for that problem. Some of them are documented. Some of them are documented in the experience. Sorry, this is documented. Some of them are documented in forms of the book and so on. Some of them are known to the architect from the experience, and some of them are there that originate as part of the creativity process. Okay. So as we can reuse, if you can reuse as much as possible, that's a good thing. When I was talking about the drivers, business, functional, constraints, and quality, the first three are relatively easy to capture. The quality is the tricky one. So usually what we have are these templates that you can translate into whichever form you want, but this is the idea. When you talk about the quality of software, you have the initial situation, so environment, you have something that is changing that initial situation, and you have the expected response. For example, you're creating an application where you tap something. So you have an application that started, you tap something, and then you get a response below 0.5 seconds. That's how you can quantify it. So you have to have a context in which you're. So ideally, you would write this for each of the quality context situations that you have in the project. Now, what about decisions? You have 2, 3, 5, 10 decisions that you are not really sure which one to take. Well, one way is to capture them and compare, okay, what are their advantages? What are the assumptions and the risks that you're making in this case? What are the scaling factors? Is it usability versus security or safety? What are the trade-offs that you're making? If we increase the performance by 10 times, we have to cut on something. So we are basically here. Ideally, if you have a driver and you have a couple of decisions how to solve that driver, which is in the problem domain, decisions are in the solution domain, you gather them and you create so-called solution. So you try to capture all of these decisions that you see, okay, there's something I need to solve. There are potential decisions. There are all pros and cons of these decisions and what is the relationship between them. So ideally, again, you would do this for every driver that you have. Now, the problem is, how do we manage all of these decisions and how do we guide the implementation through these decisions? Let's skip this. Okay, in this case, really the key is the abstraction. So when I say the abstraction, what we usually have in software architecture is not, we don't say there is a function, there is a piece of code. We have this magical word called component. Component is abstraction. There are a couple of definitions actually what a component is. That's maybe not so relevant. But if you think about the component, it's a standalone service provider. It's doing something. You don't have to map it directly into the code or function, but it's more on an abstract level. And it has some interfaces, let's not go into it all. So you're somehow able to connect it to other components. So you have decisions. From these decisions, you derive the components, and from these components, you will derive the code. That's somehow the idea. When we talk about the interfaces, again, there are several definitions what an interface actually is. We could observe it as some access point of the components and points of the coupling. When I say access point, I mean how components, functions, whatever are transferring the data. When I say the coupling, I mean if you start, for example, one component before another, and then you do execution in the reverse order, will the results change? If it changes, there is a coupling. If you start one component at one point and then another at a certain point in time, and if the result depends when you start each other with respect of each other execution time, there is a temporal coupling. if you have some external states, and depending on the states, they behave differently and you have a different result, it's a control coupling, and so on and so on. So there are many different implicit interfaces between the components. Now, if you think about all of this, okay, we said you specify requirements, you specify drivers, you specify these decisions and solutions, and if you specify all of these components into text, it's not really the best way to manage things. So one way to do that, as humans, we tend to better understand things that are visually represented. Now, a question for you. What is the difference between pictures A and B?
A standardized shape for components.
So would you say that they represent the same thing or not?
Well, in B, you have a different kind of arrow relating components 1 and 2. Otherwise, everything's the same.
Well, the shapes are different. Like
Yeah, I know, but shape doesn't necessarily mean it.
So if someone to you as a software engineer would show this A and B, let's say you first see A and then you see B, does your understanding of what you should implement, does it change? Makes sense?
I would interpret the link between components 1 and 2 differently.
Okay.
I don't know, I mean,
What about the color?
I might tell you which bit you're involved with, who knows. Is component 1 a database?
Good.
I don't know, it's a circle, not in B anyway.
And the challenge with this goes to that about the common understanding. Okay, you want to communicate your solution. How do you do it? For example, you do the visual representation, which seems to be quite practical for humans. But how do you do it in a way that everyone understands what you're trying to communicate? Because essentially, we have 3 components in a database here that communicate with each other. And somehow component 1 communicates with component 2 and is related to the database. We see it here, but for some reason, in 2 different pictures, they have a different, for example, colors or signs, or the connections are different. So what does it mean? Maybe it's clear to you, but when someone else takes a look at it, maybe you will sketch it like in the A, and someone will understand it what you actually said and sketch it in B. So after a few iterations, the picture that someone has in your team has nothing to do with what you actually said at the beginning. So that's why when we have this visual representation, what comes?
Yeah, UML.
Yeah, get there. We have these modeling profiles. So UML exactly comes first to mind. Oh, it's standardized, it works for everything. Well, it doesn't. It works in the domains where you have to have, although it's not formal, almost formal representation of what you want to do. But it doesn't work. It just doesn't work. Even with UML, the problem is, do people understand it? So in order to use UML, you have to actually have experts who understand how UML works. Otherwise, you're just okay with the arrows and boxes and that's it. It's a good basis, but what you usually have in software architecture is modeling profiles which are tailored. So modeling profiles, if you have visual element, you define what the visual element means to you. You try to limit them as much as possible. You try to choose proper colors, symbols, size, position. Interesting things. Colors and symbols, they can vary from different domains and they can vary geographically. So in certain parts of the world, people prefer symbols. In other parts of the world, people prefer colors. Yeah, basically, size of the text and so on. So it really also depends on the domain in which you work. In some domains, people really prefer symbols. In some domains, people really prefer colors and so on. So this is taking us to this human-computer interaction actually domain. How do we represent visually something? But if you want to communicate your design, the visual representation seems to be the most adequate one. In order to communicate visual design, you actually need the visual language. So that is basically your modeling profile. Okay, UML exists. People usually build on top of it. Okay, but how many then diagrams you have? Okay, visual representation. We have 1 diagram, 2, 5, 10. how they are related, who will use it, why people will use it. Are we creating them to just one as a one action diagrams or something else? So actually inspiration for this part in software architecture comes from civil engineering. So what do you see on this picture?
A house plan.
House plan, yes, we have a tree next to a house, so that's probably the exterior, but what else do we have?
Oh, you've got like the projections,
Yeah, which are?
floor plans, wall plans.
Yeah, maybe this is electricity and the lights and so on. Maybe this is the plumbing and where the pipes are with water. I don't know because it's blue. So,
Someone, the blue T is for electricians, apparently.
sorry?
Someone on Zoom said that blue T is for electricians.
Oh, okay. Yeah. Okay. We already see the issue with the modeling profile. But you can have a different views on the system, and the same is with the software system. So these are architectural views. So we basically create diagrams that represent different views on the system. So for example, there are many of these view types. One of the most commonly used these days is called C4, but there are many of them. I will not go into details. So for example, you could have really high level representation of your system. This is your system. This is someone who is using a system, and these are external systems with which your system is interacting. And then you have the view on the same system where you say, okay, these are the different components of my system, different functionalities, high level functionalities. Or you can even go further, almost not to the level of classes, but almost there because we're talking about the abstractions. So you really, for each of the functionality, you go deeper and deeper. How many of these you need to create? That really, it depends on you, what you're trying to achieve. Now, let's say we want to go with the visual representation. We know what are components, what are interfaces. We have different views. We need a process. Because once we create some sort of documentation, we usually want to keep using it, usually. If you don't update it, then it's not only useless, it's harmful. Because if your documentation doesn't represent your system faithfully, people will get wrong ideas and they will lose time. So that's a really bad idea. So, okay, for example, you want to integrate these architectural activities into agile process. In agile process, you have backlog, you have planning of the sprint, and so on and so on, daily scrum. One of the things that seems to work these days is when you have a sprint review, that you actually do the review of your architecture as well. You update your models and documentation, and then you proceed. You create some new requirements, you create the drivers, make new decisions, modify your representation, and then you move on. Okay, so it seems that this explicit software architecture is really great and everything is solved. And yes, the problem is that almost no one is using it. And there is a good reason why almost no one is using it. And the reason is that there is an overhead. And the overhead for that comes from, you have to first create the first version of all of this. You have to decide on the templates, on the modeling language, on the views, on the process, on everything. Once you have it, you have the maintenance effort. So every time when implementation changes, you actually have to change your representation and documentation. So you have to ensure this consistency, traceability between the implementation and the representation. Then you have the effort about consuming documentation. It's not the same if you have one diagram and you're trying to understand something, or if you have 100 diagrams and you're trying to find your diagram where something is specified. Or if you have 100 pages of a book. So code is something like a very boring book for robots. The documentation is abstraction of that very boring book for robots. So it's a very boring book for humans. So it really doesn't work. And then you also have to follow a process. You actually have to follow a process if you want to achieve this. And that also introduces an overhead. So are you actually getting any benefits, or what are the benefits that you're getting compared with the overhead that all of this is introducing? So people just then return back to the coding and, okay, that seems to work, and somehow I manage, and okay. But it doesn't solve the problems that we said at the beginning. It's not really reproducing your success. Okay, so it seems that regardless if you do implicit or explicit architecture, we always end up doing the same things. There is a problem that we want to solve. We come up with a solution. We do the coding. There is some process. Difference is whether all of this is implicit or explicit. In both ways, we have ways to fail. The first one, we're not able to reproduce or guarantee anything. And the second one, the overhead could be so big that this really doesn't make any sense, and we sort of get lost in the processes, and that sort of jeopardizes our progress. So the answer is really somewhere in between, and that's the customization. So whenever you want to do something in terms of the processes, documentation, or whatever, whenever you want to do something explicit, the first question is why? What is your motivation to do this? For example, you want to tackle the issue of onboarding new members, okay? Someone is going to produce documentation or a process or something for that. Who is going to do that? Okay, who is going to be the consumer, your team members? What would consumer gain from this? What would a team member gain from it? So after this is done, they will, for example, be able to set up their IDE, they will set up all the plugins, and they will download the code. What can they do with this? They already compiled the code and run the tests. It's a very concise objective what you want to achieve. And if you write documentation just for this, not, oh, there is another link if you want to, no, just this. It can be visual, it can be process, it can be whatever. We'll get to that in a moment, but this is what you're trying to achieve. Now, how to do that? Well, how do you go from why to how do you actually achieve this? Customization. Based on what you want to achieve, you actually determine your modeling profile. So that visual language, you actually choose views that you need. You implement some process if you need a process. You choose the tools. So you customize yourself towards the goal that you want to achieve. And then we come to the what. So if you know why are you doing something, if you know what you want to achieve, then what becomes obvious. So for example, onboarding of the new members, then you choose, I don't know, 3 boxes with the different colors. What do they represent? 1 or 2 diagrams, okay? Then you basically know what you want to produce as documentation. And then the tools, you, for example, decide, okay, new members, they're going to access it through the Confluence and so on. Let's put it on the Confluence or somewhere else. But it's really very specific to the goal that you want to achieve. Okay. After you do this, you do the cost-benefit analysis. Even if you tailor something to a specific need, that this makes sense. So if we have a new developer, how much time will it take for a developer to gather all of this info by themselves and be able to compile the code and run the tests? And how much effort you will need to test here to do the same thing? How much effort you will need to maintain this? How often will you maintain this? How often does this change? So as you can see, it's not really a simple approach to this. The problem that we have is we try to standardize it, we try to put it into engineering frames. The challenge is there are just so many variables that are influencing all of this. Why somehow I manage works is because the problem complexity and the dependencies between different parts of the problem is somehow more suitable for a human to implicitly, I guess, with our neural network, solve it. Instead, when we actually try to put it in the rigid engineering format. But if we do it as we usually do it, we pick up small problem and then we're able to solve it with the engineering approach, that seems to work. So just out of the curiosity, do you have any process or do you follow, or did you recognize any of the problems that we were discussing?
I think people saying what they want but not being clear about how to translate that into clear requirements is something that comes up a lot.
So for example, in your case, you could say, okay, let's define a way for translating this to the requirements. And then you choose what is the format that you want to take, what are the tools that you want to take, what do you plan to get out of that. And then you have something very concrete for a very concrete problem. If you try to tackle everything, you'll get lost. We have to try small. We have to start small problems.
I've certainly seen where bits of this have gone wrong along the lines you say there, Will. So, you know, I've been in, you know, I used to be in a department where there was a very complicated system of examinations, and the processing of the scripts that came out of that was done electronically. And, you know, people went away and spent long periods of time writing useless specifications that the people who actually wanted the system didn't understand, and which the person who then developed the thing had to throw away because they were so useless, you know, because they weren't relevant there either, you know, and how a lot of effort can go into things that aren't necessarily all that helpful.
What happened with the implementation in that case? Did they just throw away everything? And
Oh yeah, because it was already written, you know, it was already written down in the handbook for students or whatever. Oh, here is the shape of the problem. This is what we have to do.
Well, I know I, and at least one, if not two people on this Zoom call were on a big project where the place that was running it, kind of collecting all the software from lots and lots of different people together, had outsourced their kind of API design to a third-party company. And so all these research projects who'd sort of said, oh, we think we'll need this variable. So it was data from NASA. They said, we think we'll need this variable, and this variable. But then as they progressed with kind of the research, they realized, oh, actually, we also need this variable as well. But instead of just adding a line that said, download this string, this string, this string, and now also download this string, they sort of said, oh, no, that's going to be 2 weeks before we can add it to the next round of Agile. And then that will require this much tooling being added, and we'll have to charge you this much extra. And so it was kind of actually holding up science. And from our point of view, it was just silly because all they needed to do was add one more string that said, I don't know, solar wind _ L1.
That's a good example when you have this somehow I manage versus proper requirements, engineering and design that should predict that on a short basis. You actually would be able to look these changes. Yeah.
You're not always also in an environment where you can do quite exactly this. You know, if you're in industry or perhaps in RSE, I don't know. You know, I'm a computer officer rather than an RSE, but you know, we don't have anything like a oh well, you know, we'll build up to a release and then you know we do a lot of hard work and then we relax slightly and work out what went wrong and what you know change it because you know instead the work is very much more constant, quite hard work of oh this thing and now I've got to balance. You know.
Yes, in that case, there is a technique which says delay decisions as much as possible.
Yes.
Regardless of what we do, we are actually making decisions, even when they're implicit. I think it should work like this, and maybe it works for the time being, and maybe you think a bit more about the future. The catch is to recognize how critical those decisions are, and that's really hard. So one approach says, if you have a decision which results in a components that are critical for the success of your project, then it's critical decision. But that's also very big. So it's what seems to be working is that if you think in terms of what are the quality properties that are important for a project, and try to relate what you're doing to those quality properties. For example, if you have a performance that is critical in your and you're making a decision which is a quick fix, to do some quick fix, but you're introducing a problem that is affecting performance, probably you should avoid that. Or if you have a, like in this case, project in which modifiability is important to you. When you're designing something, maybe performance are not so important, but it's really important that at any point you're able to change this part of the code. The rest seems to be stable, but this part of the code you have to change often. Okay, make it in a way that you can actually change it on a short basis.
Yes, I mean, presumably that's what you're prioritizing if you say that you want to make decisions late.
But the challenge again is sometimes we just make decisions we're not even aware what are their consequences. So at least being aware of what is important in your project helps you to understand if what you're doing is really critical or not. And there's hardly basically don't know any engineering technique which is really working in practice that is able to do this for you. You have all of these processes, you can apply them, but the overhead is going to be huge. This seems to be mostly working. If you educate people and team, okay, what is critical, what we should not compromise, then any decision that you're making, any change that you're making, which is compromising this key set of the quality properties, then you might need to think, okay, how to do it. So if you think about security, for example, if the security is the main concern in your system, and if you're introducing a quick fix which is compromising security, that is a very bad idea, regardless how much performance and modifiability or whatever you're improving, it's a no-go. Any other question?
It's interesting because I think I come from more of a research background, RSE. So kind of I've been used to people just saying, we'll do something, let's go write some code. And sort of I've now been exposed to big diagrams of agile frameworks, which have huge flowcharts and pictures and everything else. And I sort of just don't want to touch it. I've not got time for that. So having something that was kind of the idea of having this happy medium that you could kind of take the bits that might be useful to you would be nice. Because I do sometimes feel it would be nicer to have a bit more of a structure, or a bit more of a kind of checks and balances whilst working through projects. And I think that would be a benefit beyond RSE, just in research software, sort of academic coding as well. But I think often it's so complicated and so tailored to kind of industrial applications that it's hard to have that filter through.
Sometimes people just create one picture that is clear to everyone on the higher abstraction level, and then they define just the terms that they're using. So if they say, I don't know, a user, probably the worst word that you can have. What is a user? We have two types of user. Oh, we have 5 types of users and 2 types of this type of user, and then it really explodes. Or if you have a component which is doing filtering or whatever, what is that? So common understanding and some high-level picture seems to be the most painless way to get there. So you sketch something, you will agree on the higher level, this is how it should work. And whenever you are struggling, you can refer to that. And if you need to have a further discussion, you can have further discussion, but you know what you're talking about, hence that related to other parts of your system. That's representation. On the other hand, what is really important is to understand what is really critical. I've been talking about this, what is really critical from the quality perspective.
I suppose there's a question about what these, you make this point about diagrams, and diagrams in some ways are useful because they're, people find them easier to think about than texts. But how do you then balance? I wonder if you have any thoughts about balancing that then with, it seems that there's a fashion in many places to go for, well, I write down a specification in a language for writing specifications, something like Open Rad tool, you go where you write down, I have users of these classes and they do this kind of thing, and database access is stuff like this. And then it goes away and makes you a database schema and boilerplate code and other things. Whereas it seems that that would be quite hard to take a diagram and turn it into that.
So I think now that we're starting discussion with what we are having, and we should always try to start discussion with why are we doing that? What we are trying to achieve.
Okay.
In a sense, okay, what is the problem that you have? Do you have a problem with onboarding a new member, or you have a problem with understanding how this works, or you have a problem with integration or testing, or what is the problem that you're trying to solve? And then you just focus on that problem and start from there. And how you're going to represent that comes as the final part. So sometimes it's a hard mental exercise, but try to reverse the situation. We usually go for the solution. This is what we're going to do.
There's a question from Matthew who, if you want to unmute and ask it, we should be able to hear. Otherwise, I can read it out for you.
I can. Yeah. Whatever.
Can you hear me? All right.
Unmute here. I'm not sure.
I think he should be able
It's
to.
fine for him to talk.
Am I coming through?
Yeah, that's fine.
Okay. Just wondering if the, this, I don't know if you'd call it philosophy or your approach that you're sort of advocating here, is there a place that you have this written down? Is there a paper? Is there a website? What sources are there for, going back and maybe disseminating this, if you will, rather than a presentation, which isn't always necessarily the best medium for doing that?
I actually have a course on that. It's starting on this Cambridge Online platform. What I presented is a collection of the papers, conclusions, extracts from the books. I didn't really do the references. Maybe I should have done that. But I was just grabbing pieces from different places. I can send you some references pointing out to these that may be quite useful. Yeah, I guess it's really the best written in the course because this is something that I've been doing for the last 10 years. It's my main domain of research. And I can send you the references. So let's put it this way. I will add the references at the end of the presentation, and I will distribute the presentation so you can I'll send you the presentation so you can.
Great, thank you.